Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 1. In today's lesson, our main focus will be on section 1. We will try to cover all questions from section 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of unit 1 and also you can have better understanding of these questions. Let's study together, let's improve together. In today's lesson, we are talking about paper 1 and total time for this exam is 1 hour and 30 minutes and total mark for this paper is 80. Question 1 says, which of the following is a vector quantity? A vector quantity should have magnitude and also direction. So this is the concept you need to understand. Should have magnitude and direction. Magnitude and direction. If you look at first one, efficiency. Efficiency is not a vector quantity. It has no direction. Kinetic energy is a scalar quantity. It also has no direction. Power also is energy per unit time, mean rate of energy transfer, or we can say rate of doing work, and this quantity also has no direction. So power is also scalar. Weight is a vector quantity. Weight has direction, mean the force of gravity, it has direction. So the answer for this question is D. So D is the right answer. Question 2 says the wind exerts a force of 225 newtons on a wind surfer. The wind surfer moves a distance of 450 meters at an angle of 40 degrees to the wind as shown in the figure. Which of the following expressions gives the work done in joules on the wind surfer? So first of all, we need to understand how do we calculate work done. Work done simply is equal to the product of force and displacement in direction of force. So very important one. Most of the time students, they simply remember work is equal to force time distance, but that is wrong. In direction of force, very important one. So you need to understand in direction of force, and this is what question is testing to figure out, do you really understand what is work done? So we have to take component of the force in direction of displacement. So first of all, we will resolve this force into two components. So this is one component of the force and this is an other component of the force. Object is moving along this line and component of force along this line is 225 cosine of 40 degrees. Component with angle, that is cosine, and opposite to the angle, that one is sine. So we have to take with direction of motion, mean with displacement. So this component is 225 cosine of 40 degrees. So this component, and we need to calculate work done. So work done has to be F times T. So component, this is the component of force we have, and this is equal to 225 cosine of 40 degrees multiplied by the distance traveled, that is 450 meters. So this is how you need to figure out. Now if you look at given options, it is given to us, if you look at A, this one is wrong because cosine 40 is missing, and this is right one. So the answer for this one has to be B. And this is sine, this is wrong. Tangent, also wrong. So the answer for this question is B. So the main concept is this. This is the main concept. This part, most of the time, students, they remember this part, but they don't understand this part. So you have to take displacement in direction of force. So that's the reason we have resolved this force into two components and we have taken component of force in direction of displacement. So these two, they have to be in the same direction, means the force and displacement. Question 4 says a force extension graph for a spring is shown in the figure. Which of the following gives the work done in joules to extend the spring by 0.30 meters from its original length? Work done from the original length means extension is equal to 0. So in this case, simply we need to calculate area. So if we draw this line here, when extension is equal to 0.30 meters, we can also find out value of the force. Value of force we can find from y-axis. So value of force, and value of force is 2.5 newtons. So simply we need to find out this area. So work done in this case is equal to area under this graph. So this area is representing work done, and this area is equal to 1 by 2, means this is just a triangle, and base of this triangle is 0.30, and the height of this one is 2.5. We can also say this is 0.5 times 0.30 times 2.5. So simply this area you need to calculate. So the answer for this question has to be B. So B is the right answer. Question 5 says two forces form a Newton's third law pair. Which of the following statements is not true? For Newton's third law pair, we need to understand few points. So Newton's third law pair. The forces will form Newton's third law pair if there are certain conditions need to be fulfilled. Newton's third law pair. The first condition is that same magnitude. So we can simply write down two forces. They will form Newton's third law pair if they have the same magnitude, opposite directions. Opposite directions. So they should have opposite directions, and two forces, they have to be of same type. Means two forces can be gravitational forces, two forces can be pushing forces, they can be pulling forces. They have to be of same type. So this is very important one, same type. If two forces they form a Newton's third law pair, for example, they can be gravitational, both of them they can be gravitational, or they can be normal reaction force, means the pushing forces, but they cannot be of different types. So this is very important one. And the fourth one, act on different objects. Act on different objects, not on the same object. Act on different objects. So this is what you need to understand for Newton's third law pair. If these conditions are fulfilled, then two forces, they will form Newton's third law pair. If you look at given options, the forces act on the same object. No, they have to act on different objects. So this statement is not true. So the answer for this question is A. But if you look at the second one, same magnitude, this is true. The forces act for the same time. Yes, of course, you cannot touch without being touched. For example, if I touch my left hand for 1 second, left hand will also touch my right hand for 1 second. So you cannot touch anything without being touched. So time is the same. So if you want to write down here, you can also say same time, but this is something that is very easy to understand. Same type and same time. So this is also true. Same type, yes, this is also true. So the answer is A. So this is very important to remember. You cannot touch. You cannot touch without being touched. Being touched. Something beautiful. You cannot touch without being touched. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 1. In today's lesson, we will talk about projectile motion, we will talk about momentum, we will talk about forces, and we will also talk about energy. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 6 says, a student determined the acceleration of free fall. She measured the time t for a ball bearing to fall from rest through a distance s. She repeated this for a range of values of s. Which row of the table shows the graph that would give a gradient equivalent to g? So for this question, simply she dropped a ball bearing from certain height, and the height is given to us. In this case, this height is s. So simply we can draw here, this height is s. For this one, we need to determine value of g, and this ball bearing started from rest. U is equal to 0. In this case, acceleration is constant, so simply we can say s will be equal to ut plus 1/2 at square. As initial velocity is equal to 0, so simply we can say this is equal to 0. So here we will have 1/2 at square. We can also write down this one 2s. This will be equal to at square. Now if we sketch a graph between 2s and between t square, gradient of the graph will be equal to a. We can simply compare this one with straight line equation, y is equal to mx. So this quantity is s, this quantity is y, so the gradient in this case will be equal to a, and a in this case is equal to g. A is equal to g. So the answer for this question has to be B. So B is the right answer. Pretty straightforward question. If you have done this experiment, simply you can look at the given options and you can find the answer. Question 7 says a car travels with a velocity of 3 meters per second. The car accelerates uniformly in a straight line for a distance of 15 meters. The final velocity of the car is 5 meters per second. Which of the following expressions gives the acceleration of the car in meters per second per second? For this question, it is given to us the car is moving in a straight line. So car is moving in a straight line. So we can also simply draw the car here. So this one is the car. Initial velocity of the car is given to us, that is 3 meters per second, and final velocity of the car we have, that is 5 meters per second. And the distance traveled by the car is given, so we can also write down the distance travel. Distance travel is 15 meters. So this is the distance traveled. We need to calculate value of acceleration. This is what we need to calculate. Acceleration is constant, so simply we can use 2as is equal to v square minus u square. We need to calculate value of a, so we can write on a will be equal to v square minus u square divided by 2s. Value of v is given, that is 5, and value of u is given, that is 3, divided by 2 times 15. Now if you look at given options, option D, so this is our right answer. So option D is the right answer. So this is how you can figure out. Question 8 says an object accelerates from rest down a frictionless slope. The object moves a distance of 20 meters. The slope is at an angle of 23 degrees to the horizontal as shown in the figure. Which of the following gives the final speed of the object in meters per second? Main question is simply asking us what will be the speed of the object at this point. So we can say this speed is v. So this is what we need to calculate. What is value of v? In order to answer this question, we can simply draw first of all the force acting on this object. So this is the gravity. Gravity is acting vertically down. And we can also resolve this gravity into components. So this is one component and this is the other component of this. Otherwise, the better way to draw this one is the second component we can draw here. So this is an other component of weight, component of gravity. So these are two components. This angle will be 23 degrees, and this component is perpendicular to the plane, and this is along the plane. If weight of object is mg, so this component will be mg sine of 23 degrees. So in this case, the net force acting on this object, we can say F net, that will be equal to mg sine of 23 degrees. And this is also the reason, very important point, if you understand it's wonderful, if you don't understand, let's try to understand now. So imagine that if I place this marker on this box like this marker just stay here, but if I increase the angle with the horizontal, this marker will go down. Why this marker go down? This marker will go down because there is a force acting on the object down the plane, and that is component of gravity. And so that's the reason it will go down. So from here we can find out value of A. So we can say MA, this will be equal to mg sine of 23 degrees. We can cancel m with m, so A in this case, this is equal to g sine of 23 degrees. This object started from rest, so u is equal to 0 meters per second, and acceleration is constant, so simply we can write down v square minus u square. This will be equal to 2as, and in this case we are taking down the plane, this direction we are taking as positive. So we can write down v square will be equal to u square plus 2as. U is equal to 0, so this one is equal to 0. So simply we can write down 2 times A is equal to g sine of 23 degrees, and S is equal to 20 meters. So the value of V, simply you have to take square root on both sides. So this is the final answer, and if you look at the given options, we have 2, so we can write down also in a better way. We can say this is 2 times 9.81 times 20 times we have sine of 23 degrees. So this is a better way of writing. So this is our final answer, and if you look at given options, C is the right answer. So this is the answer. So this is how we can answer. There is an other way to answer this question. We can also use conservation of energy. Let me explain you with the help of conservation of energy. Conservation of mechanical energy in this case, because there is no friction, so we will say conservation of mechanical energy. At this point, object has certain gravitational potential energy, and we can take our reference line. So this is our reference line, means the GPE at this point, at this level, GPE is equal to 0. We can say GPE here is equal to 0. So at this point, object will have kinetic energy, and here kinetic energy of the object is equal to 0. Now from here we can write down change in GPE, that has to be equal to the change in kinetic energy, and change in GPE we can write down that has to be equal to mg delta h, and that has to be equal to 1/2 mv square, because initial speed is equal to 0. We can further simplify this. We can cancel m with m, means it is not depending on mass. So this is very important point. It doesn't matter I have a big box, I have a small box, they will reach this point with the same speed if we release them from the same height. A beautiful point you need to understand. So from here we can say v square, this will be equal to 2g delta h, root of this one. So we have here 2 and we have g, that is equal to 9.81. So how we can find the height? So let me little bit clean this one. How we can find the height? Means this height, how we can find this? We have 20, we have angle, so this has to be 20 sine of angle, sine of 23 degrees. So we can write on here, so this is 20 times sine of 23 degrees, root of this. So this is the value of V. So answer is C for this question. A beautiful question. Try to do this one using these two different methods. This will help you to improve your understanding of forces and kinematics. Question 9 says a ball bearing falls at terminal velocity through a liquid. The temperature of the liquid increases and ball bearing falls with a greater terminal velocity. Which row of the table is correct as the temperature of the liquid increases? For the first case, it is given to us ball bearing is falling at terminal velocity, and terminal velocity means the velocity is constant. So here is the drag force. So in this case, we can say this is the mg and this one is the drag force. Object is falling at terminal velocity, it means these two forces are equal. So Vt means the terminal velocity, this is constant, so resultant force is equal to 0. Then temperature of the liquid increases. As temperature of the liquid increases, viscosity of the liquid will go down and terminal velocity of ball bearing this increases, but it is again moving at constant velocity. So we can redraw. So here is mg and here we have drag force. So this is the drag force Ft. It is falling again at constant velocity. It also means that these two forces again they are equal. So Fd is equal to mg, and in the first case Fd drag force, this is also equal to mg. So it simply means that viscous drag remains constant and viscosity of the liquid decreases. So the answer for this question has to be B. Drag force remains constant, viscosity decreases, so the answer for this question is B. So B is the right answer. So this is how we can answer this question. When body is falling at constant velocity, terminal velocity, resultant force has to be equal to 0. Question 10 says two identical springs are arranged in series. A force of 45 newtons is applied to the springs as shown in the figure. The springs extend a total distance of 15 millimeters. Which of the following expressions gives the stiffness of each spring in newtons per millimeter? So for this one we need to understand when the springs they are connected in series, force on each spring is the same. It means 45 Newton force is acting on this spring and 45 Newton force is acting on this spring as well, because these springs are massless. So springs are massless, so we can say springs are massless. So force on each spring is the same. So force on each spring is the same. On each spring is the same. So this is the main concept you need to understand, is the same. If this concept is clear to you, now we can simply write down total extension we have, that one has to be equal to x1 plus x2, and this is equal to x, means the total extension. Total extension is given to us, that is equal to 15 millimeters. So this is 15 millimeters, and x1 we can simply find out. This has to be equal to f divided by k plus this has to be f divided by k. Now if we simplify, we can say this is 2 times f divided by k, and this is equal to 15. So from here we can say k has to be equal to 2f divided by 15. So we have value of force that is equal to 45 newtons divided by 15 millimeters. So this is in Newton. So this is our final answer. If you look at given options, so option D is correct. 2 times 45 divided by 15. So the answer is D. So the beautiful question, when springs are connected in series, each spring experience the same force. because we assume springs are massless. And if that is clear to you, then simply you can answer this type of problems. So this is our main concept for this question. Question 11 says a rock falls from rest through a small distance s to the surface of Mars. The rock hits Mars with velocity vm. Another rock falls from rest through distance s to the surface of Earth and hits Earth with velocity ve. Calculate the ratio between vm and ve. Acceleration due to gravity on Mars is equal to 0.38 g. So we can simply write on, first of all, acceleration on the surface of Mars is equal to 0.38 g. So we have two situations. So we can consider the first case where we have the Mars. So here is for the Mars, and it is given to us the distance from the surface of the Mars. This is s. So this is, let's say, the surface of the Mars, and it is started from rest, so u is equal to 0. And the second case we have for our planet on Earth. So we can say this is for Earth, and it started also from rest. So we can say u here equal to 0 as well. And the distance fallen is s. So we need to find out simply what is the velocity when the ball just hit the surface. When the ball just hit this surface, what is that velocity? That v we have to find out, and that is ve. And same for the Mars. When it hit the surface of the Mars, what is that velocity? That is vm. So we can say this is v sub m. We need to find the ratio between vm and ve. So first of all, we can find out vm. Vm, in this case, acceleration is constant, so simply we can use v squared minus u squared. This has to be equal to 2as. So we can say v squared, this has to be equal to u squared plus 2as, and in this case we are taking downwards as positive. U is equal to 0, so this is equal to 0. So we can say v, simply this will be equal to 2 times value of gm, and gm is equal to 0.38 times g times s. So this is vm. So we can say this is value of vm. So we can say this is vm. And same we can do for ve. So ve has to be equal to 2as root of this. So we can say this is 2 times g times s. So this is value of ve. Now we need to find the ratio between these two. So the ratio between these two. So vm divided by ve. We have value of vm, that is 2 times 0.38 times g times s, divided by, we have 2 times g times s and the root of these two here. Now from here simply we can cancel this g with this g, this 2 with this 2, and this s with this s. So if we take square root of 0.38, we will get that will be equal to 0.62. So this is the ratio between vm and ve. So it means vm is slower, and this is equal to about 0.62 of ve. For the answer of this question, this is the answer. But you can compare how fast is ve. So vm is equal to 0.62 times ve. So the speed on the surface of the Earth is faster because value of acceleration is greater, and this value is lower because acceleration on the surface of Mars is smaller. So this is our final answer. Question 12 says a man dives from a platform into a swimming pool. The platform is 12 meters above water surface as shown in the figure. So this is 12 meters above the surface of water. Question A says state how the graph shows that the man's initial vertical velocity is 0. So we have here displacement against time graph, and this is vertical displacement against time graph. Vertical displacement against time graph. And we need to understand gradient of dt graph means the gradient of displacement against time graph represents velocity. So simply we need to draw the tangent line and we need to find the gradient. So if we draw the tangent line here, gradient of this tangent line is equal to 0. So simply we can say as initial gradient is equal to 0, it means that initial vertical velocity is equal to 0. So simply we can say as initial gradient is equal to 0, so the initial vertical velocity is also equal to 0. For the second part, we need to determine the vertical velocity of the man as he enters the water. So the person will enter water at this point, means the displacement will be equal to 0. So at this point, we need to find out the velocity. What is value of v at this point? Then this person started from rest, so we have the initial velocity that is equal to 0, and we have value of displacement, and it is in free fall, so the acceleration will be equal to g, means a will be equal to g. Now simply we can use kinematic equation, so we can write down v square minus u square. This will be equal to 2as. For this question we need to calculate value of v square. We can say this will be equal to u square plus 2as, and u is equal to 0, so we can say this is equal to 0. So simply we left with v, and v will be equal to 2as, and a in this case is equal to g, so we can say this is 2gs root of this one. So we have 2 and g is equal to 9.81, and value of s that is equal to 12. Now simply we can solve this one, and we will get our answer is 15.3 meters per second. So this is the vertical velocity when the person is at this point, means just enters the water. So the value of v at this point is equal to 15.3 meters per second. So this is one way you can answer this problem. And other way to answer this question is we can also draw the tangent line at this point, and we can find the gradient of that tangent line. So in this case we can draw here tangent line, and we can find the gradient of tangent line, and that also will be equal to about 15 meters per second. So the answer for this question is 15.3 meters per second. So this is our final answer. Part B says, before entering the water, the man has a constant vertical acceleration. After entering the water, the man has a constant vertical deceleration. Draw the velocity time graph for the man on the axis below. So if you look at displacement time graph, we have already said that initial velocity is equal to 0. And at time 1.5 seconds, we have found velocity of v that was equal to 15.3 meters per second. Now if you look at this point, gradient is 0. It means the final velocity is also equal to 0. We can also understand this question a little bit in a different way. First of all, we can imagine at this point initial velocity of the person is 0, and this person start falling downwards. And when this person hit the water, we can say at this point the velocity of the person, this is equal to 15.3 meters per second, and acceleration is always downwards, so a is equal to g. And finally, when person is somewhere in the water, its velocity becomes 0. So at this point v2 is equal to 0. But when the person is inside water, acceleration is upward, so person will decelerate. So this is direction of acceleration when the person is inside water. This part is representing inside water. So direction of acceleration is in opposite directions. By convention, we take up is positive. So if we take up is positive, it means the velocity will be negative, so v will be negative in this region, and acceleration also will be negative. So we will say A is equal to G, but this has to be negative. So acceleration is negative. But acceleration here, this one will be positive. So if we have understanding of this point, now we can sketch the graph. So it started from rest and at time 1.5 seconds, 1.5, so velocity is about 15.3 meters per second, and then at time here velocity again become 0. Now simply we need to connect this one. We can draw the straight line because acceleration is constant, so we can draw a straight line here, and again acceleration is constant, so we can draw the straight line here. So this is how you can sketch. You can also see from here acceleration has different direction. Here we can see this gradient is negative, and here we can say the gradient is positive. So this gradient is negative and this gradient is positive. So this acceleration has positive direction and this one has negative direction. We can also see from here. So this is how you need to sketch this graph. Question 13 says a high-speed train accelerates from rest along a straight horizontal track. The final speed of the train is 76 meters per second. Show that the useful work done to accelerate the train is about 2 gigajoules and mass of train is given to us. So first of all, we can simply sketch this. So we can simply sketch. So in this case, we have a train and this train started from rest. So the u for train is equal to 0 meters per second. And the final speed of the train, we have final speed of the train, that is equal to 76 meters per second. So in this case, the useful work done on this train will be equal to the change in kinetic energy of the train. So we can say useful work done on train, useful work done. So simply in this case, we can write down useful work done on train, this is equal to change in kinetic energy of the train, and change in kinetic energy of the train is equal to 1/2 mv square minus 1/2 mu square. So we have 1/2 mv square because this is equal to 0, because u is equal to 0, so this is also equal to 0. So we have 1/2 m is 7.2 times 10 to 5 kgs, and value of v is 76. So if we solve this one, we will get 2.08 times 10 to 9. So this is about 2 gigajoules. So this is about 2 gigajoules. So this is our final answer. So if you have written these steps, you will get 2 marks. 1 mark for writing the equation and the second mark for calculations and correct answer. So we can say this one, actually the better way of writing this one is the better way, because this is 2.08 up to 2 dp. We can say this is 2.1 times 10 to 9 joules. So this is about 2 gigajoules. So this is better way of writing because this is greater than 5 are greater than 5, so this has to be 2.1. So this is our final answer. Part B says the train accelerates for 180 seconds. The train has an input power of 60 megawatts while accelerating. Determine the work done against a resistance as the train accelerates. So in this case, we need to understand total input energy. We can say energy input. We can write down in a better way. We can say input energy in this case. Input energy, this one has to be equal to useful work done. So we can say useful work done plus work done against a resistance. Work done against a resistance. For this question, we need to calculate work done against air resistance. Work done against a resistance. So simply this one has to be equal to input energy minus useful work done. So we have minus useful work done. Input energy simply we can calculate because we have input power and the time is given to us. So the input energy will be 16 times 10 to 6 multiplied by time 180 and minus useful work done. We have already calculated 2.08 times 10 to 9. Now if we simplify this one, we will get our final answer will be equal to 8.0 times 10 to 8 joule. So this much work is done against a resistance, and this is our final answer. This question has 2 marks. The first mark you will get if you have calculated input energy correctly. You will get 1 mark, so this will be 1 mark. And the second mark you will get if you have got the right answer. So this is how you will get these 2 marks. That's all for today's lesson. I hope this video was helpful. If this video was helpful, please like and subscribe because your encouragement is very important. And if you need more help, you can also join Patreon. And Patreon you will find more resources, and also you can connect with me directly. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 1. In today's lesson, we will start from question number 14 and we will discuss some important questions about momentum and forces. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these concepts, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 14 says a sportsman hits a ball with a bat. The ball leaves the bat at a speed of 37 meters per second at an angle of 53 degrees to the horizontal as shown in the figure. Calculate the horizontal distance traveled by the ball before returning to the height it was hit from. It simply means that we need to find out the distance between these 2 points. So horizontal distance between these 2 points. So we can draw this line here. So we need to find out the distance between these 2 points. We can also mark this one x. We need to find out value of x. This is what we need to calculate for this question. Now we need to highlight some important point, the informations we can get from this graph. First thing, we can draw this arrow. This arrow is representing the final velocity, and the magnitude of the final velocity at this point has to be the same as magnitude of initial velocity at this point, because mechanical energy is conserved because there is no air resistance. So mechanical energy is conserved. As mechanical energy is conserved, it means that kinetic energy at this point and at this point has to be the same. At the same height, kinetic energy has to be the same. So that's the reason we can say the magnitude of this velocity is also 37 meters per second. At this point, we can also say vertical component of the velocity, this one has to be equal to 0. So we can also infer from this graph. And at this point, vertical displacement SV has to be equal to 0 because the ball started from this height and come back to the same height. So we can also draw like this. Ball went up like this and come back to the same point. So the vertical displacement is equal to 0. So these informations we have. Now simply we need to use kinematic equations and we can find the answer. We need to calculate x for this question. So x has to be equal to uxt. We are talking about horizontal motion. The beauty of projectile motion is that you can treat horizontal motion and vertical motion separately. So here I'm talking about horizontal motion. So I will be writing here horizontal. So I'm talking about horizontal motion. For horizontal motion, we can say x is equal to uxt plus 1/2 at square. We are taking this is over origin. And along horizontal, acceleration is equal to 0. So it simply means that this term will be equal to 0. So we only left with ux times t. So this is x. So to calculate x, we need value of ux, we need value of time taken from this point to this point. How we can calculate ux? So we can simply resolve initial velocity into two components. So this is the horizontal component, and here we have vertical component. Horizontal component, in this case we can say ux, this will be equal to 37 cosine of 53 degrees, and this will be equal to 22.3 meters per second. And vertical component of initial velocity, this will be equal to 37 sine of 53 degrees, and if we solve this one, we will get 29.5 meters per second. So we have horizontal component of velocity, so we can write down here horizontal component of velocity is 37 cosine of 53 degrees times time. So we have calculated this value, that is equal to 22.3. Now simply we need to calculate value of t. To calculate value of t, we have different options, but I will be using the simplest way to calculate value of time. We can simply draw arrow here, means we can divide this motion into two parts. So we can calculate value of t, then we can multiply by 2 to calculate total time of flight. So this t is the total time of flight. This is representing total time of flight. So this is total time of flight. So we can write on here. So this is total time of flight. How we can calculate this one? First we can calculate time taken from this point to this point. So we need to consider vertical motion. When you need to calculate time, most of the time you have to consider vertical motion. For vertical motion, we can write down v is equal to u plus a t. Vertical component of velocity at this point is equal to 0, and initial component of vertical velocity is 29.5. In this case we are taking up is positive, so this will be positive, plus we have a, that is equal to 9.81 is equal to g, but this one has to be negative because acceleration is downwards. So g is downwards, so this has to be negative times t. So from here we can say t will be equal to 29.5 divided by 9.81. If we solve this one, we will get 3.01. So we can say this time is t1. But total time of flight, in this case t, this has to be equal to 2 times of t1. So we have 2 multiplied by 3.01, we will get 6.02. So this is the total time taken. So this is total time taken. Now simply we need to write down here total time taken, that is equal to 6.02. And if we solve this one, we will get 134.1 meters. So this is our final answer. This is how you need to answer projectile motion problems. I hope this one is clear to you. So always write down what kind of information you can get from the given data and from the graph, and then just use the formula, that's all. And be careful with directions. So in this case we have taken up is positive, so a has to be negative. Question 15 says the diagram shows a machine used to launch tennis balls in a horizontal direction. The machine is on frictionless wheels. Before tennis ball is launched, machine is stationary. Explain in terms of momentum why the machine starts to move as the ball is launched. This question is basically about conservation of momentum. When we need to apply conservation of momentum, always we need to define a system. For this question, our system consists of ball and machine. For this question, it is given to us initially machine is stationary. So it simply means that initial momentum is equal to 0. So we can say this is our 1 point. We can say initial momentum of the system is equal to 0. Now we need to look at this system. Is there any external force acting on the system or not? If you look along horizontal, there is no external force acting on the system. So it means that total momentum is conserved. So we can say total momentum remains constant. So we can also say total momentum is conserved, means total momentum of the system is conserved because no external force on the system, no external force on the system along horizontal, no external force on system along horizontal on system. So this is the second point you can write down. Now if this ball, due to internal force, if ball go to the right, means it gains momentum to the right, so the machine has to gain momentum in the opposite direction. So it simply means that we can write down as initial momentum has to be equal to final momentum in this case. So initial momentum is equal to 0. So we can say, let's say mass of this ball is m, speed of this ball is v, and the mass of this machine, let's say, is capital M, and the speed of this ball in the opposite direction, let's say this is u. So we can take one direction as positive, we can take to the right is positive. So the momentum of this one, I mean the sum of momentum of this, vector sum of momentum of this plus this has to be equal to 0. And so we can say m times v, so this is positive, plus we have minus capital M times u. These two has to be equal in magnitude. So we can say mv minus mu has to be equal to 0. So that's the reason machine must have speed in the opposite direction, mean machine has to move. So these are the points you need to understand to answer this question. Now let me show you the answer, how you can write down your answer. So this is how you can write down your answer. You can mention total momentum of system is conserved because no external force acts on the system. If you write down, you will get 1 mark. The second mark you will get initial momentum of system is 0, you will get the second mark, and third mark you will get if you have written machine and ball have equal but opposite momenta, so they have to move in opposite directions. So you will get 3 marks. Part B says calculate the velocity of the machine just after the ball is launched. The velocity of the ball is given to us, mass of the ball is given, and mass of the machine is given. So we can use small letter m. We can say the mass of the ball is equal to 0.056 kgs, and we can use letter capital V for the velocity of the ball, and velocity of the ball is 4.5 meters per second. And for the mass of the machine, we can use letter capital M, and mass is equal to 2.9 kgs. We have already discussed this machine will move to the left, so we can use letter U for the speed of the machine. Mean this machine will move to the left. Even if you don't know it will move to the right or it will move to the left, we can also answer this question. So let me explain you how you can answer. If you don't know this will move to the left or it will move to the right, so simply we can write down initial momentum. This has to be equal to final momentum. Initial momentum is equal to 0. So we can say this is equal to 0. And the final momentum, we can take one direction positive. So we can take to the right is positive. If we take to the right is positive, so this velocity will be positive. So we can write down m times v, and we don't know direction of velocity of the machine, so simply we can use plus sign here. So it has to be capital M times u, means the vector sum of the momentum. This one is positive, but we don't know this one. If we got positive answer, it means direction of u is also in direction of v. If we got negative answer, means negative value of u, it means it will move in the opposite direction. Now simply we can plug in values. So we have m is equal to 0.056, and we have value of v, this capital V is positive, so this is 4.5 because we have taken to the right positive, and plus we have mass of the machine, that is 2.9, and we don't know what is value of u. We can take this term on the left side, so we can write down this is 2.9 u. This will be equal to negative 0.056, means I have taken this one to the left, multiplied by 4.5. We need to find out value of u, so this is negative 0.056 multiplied by 4.5 divided by 2.9. So if we solve this one, we will get value of u, that will be negative 0.0869 meters per second. And this negative sign simply tells us that direction of velocity of machine is in opposite direction of velocity of ball. So that's the reason we got negative sign here. So the final answer we can write on 0.0869 meters per second. So this is final answer. So if you got this right answer, you will get 3 marks for this question. So this is how you need to approach a beautiful way. Always you have to take one direction as positive. If it is not given in the question which direction you have to take positive, always take to the right positive, because by convention we take to the right positive, and up also we take by convention positive. So this is our answer. I hope this video was helpful. If this video was helpful, please like and subscribe, because your encouragement is very important. And also leave some comments in the comments section. And if you need more help, you can join Patreon. On Patreon, you can be connected with me more directly, and I'll be able to help you more on Patreon. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 1. In today's lesson, we will start from question number 16. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 16 says, a small spherical air bubble moves upwards in a glass of water. The drag force on the bubble can be calculated using Stokes' law. For part A, state the condition needed for Stokes' law to apply to the bubble. Stokes' law is only valid for laminar flow. So simply we can say flow must be laminar. Flow around sphere must be laminar. Or you can say flow must not be turbulent. Flow must be laminar. So if you write on this one, you will get 1 mark. For part B, it is given to us the bubble moves upwards at a constant velocity. The volume of the bubble is given to us. We need to show that upthrust on the bubble is equal to this, and density of water is given to us. So for this question, first of all, we need to understand upthrust is equal to weight of fluid displaced. Upthrust is equal to weight of fluid displaced by bubble. Weight of fluid displaced, and weight of fluid displaced will be equal to mass of the fluid displaced times g, and mass of the fluid will be equal to density of the fluid times volume of the fluid displaced, and volume of fluid displaced in this case will be equal to volume of bubble times G. So simply we can say upthrust from here, upthrust, this is equal to rho Vg. Rho is the density of the fluid and V is the volume of fluid displaced. So I'll be writing here volume of fluid displaced. So this is upthrust. Now simply we need to plug in values. We have value of density, that is 998 kgs per cubic meter, and volume of bubble, that is equal to volume of fluid displaced, because this is fully submerged in the water. So we can write on volume is 5.3 times 10 to minus 11, and value of G is 9.81 newtons per kg. Now if we solve this one, we will get 5.19 times 10 to minus 7. So this is our final answer, and this is how you need to answer. And this question has 2 marks. If you have written first of all this formula, you will get 1 mark. and the second mark you will get if you have got the right answer. Second part says the bubble moves upwards at a constant velocity of 0.035 meters per second. Deduce whether Stokes' law applies to the bubble. You may ignore the weight of the bubble. So in this case, weight of the bubble we can ignore. So if we consider forces acting on the bubble, then the force acting on the bubble will be upthrust. We can say this is U. And if we ignore the weight, then only force acting downwards, this force will be the drag force. Upthrust we have already calculated. Value of upthrust was 5.19 times 10 to minus 7 newtons. And drag force simply we can calculate by using Stokes' law, 6 pi eta rv. And this is the velocity. And if these two forces are equal, it means Stokes' law applied. If these two forces are not equal, it means Stokes' law does not apply. So we need to calculate value of Ft. So Ft is equal to 6 pi eta rv. We need value of V. Volume of the sphere we can write down. Volume will be equal to 4 by 3 pi r cube. Value of volume we have, that is equal to 5.3 times 10 to minus 11. We need to find out value of r. So we can write on here. So we need value of r. So r in this case will be equal to 3 times 5.3 times 10 to minus 11 divided by 4 pi, and the cube root of this one, cube root of this. And if we solve this one, from here we will get value of r, that will be equal to 2.33 times 10 to minus 4. So this is value of r. Now simply we need to plug in these values. So we have 6 pi, value of eta is given, means the value of viscosity is given, that is 9.5. So we can write down value of viscosity, that is 9.5 times 10 to minus 4, and we have value of r, that is 2.33 times 10 to minus 4, and we have value of velocity, that is 0.035. So we can write down here 0.035. Now we need to simplify this one. If we simplify, we will get in this case 1.46 times 10 to minus 7. So in this case, Fd is not equal to upthrust. So we can simply conclude from here, Stokes' law does not apply. So we can say Stokes' law does not apply. So this is how we can conclude from this, does not apply. So if you have written the final conclusion and you have done these calculations for this question, you will get 4 marks. The first mark is if you have calculated value of r, if you have used this formula, you will get 1 mark. So this will be the 1 mark. And the second mark, if you have used this formula, you have written this one, you will get an other mark. And if you have got the value of drag force, you will get 3rd mark, and the 4th mark you will get if you have done the comparison. So for this question you will get 4 marks. If you have written these steps, you will get maximum 4 marks. Question 17 says the photograph shows a floating object called a buoy. A long chain attaches the buoy to a very large mass at the bottom of the sea so that buoy remains stationary. Remains stationary means that the net force acting on the buoy in any direction is equal to 0. We can say net force F net along y is equal to 0 and F net along horizontal, means along x direction, is also equal to 0. It is also given to us water flowing past the buoy causes a horizontal force of 260 newtons on the buoy. The chain exerts a force F on the buoy at an angle of 33 degrees to the vertical as shown in the figure. So the best way to answer this question is, first of all, we can draw the free body diagram. So we can draw here. So this is the object. On this one force is acting to the right. This force is 260 newtons, and there is a tension in the chain. So this force is here. So this is F, and we have up thrust acting on this one, that will be in upward direction. So we can say this is the up thrust. So you can draw this arrow a bit longer. So this is the up thrust, and there is a weight of this boy that is acting down. So we can say this is mg. So this is how we can draw the free body diagram. These are the forces acting on this one. Now we need to understand how forces along vertical they are balanced, and also along horizontal. If we look at vertical, so along vertical we have up thrust that is acting up, and this one has to be equal to mg because mg is down. And we have component. We can resolve this force into two components. We have one component here, this is acting vertically down, and one component is acting to the right. And component acting down, this component of the force, this is F cosine, because this is with angle, F cosine of 33 degrees, and this one has to be opposite to the angle, F sine of 33 degrees. So we can write on here, we have F cosine of 33 degrees. So up thrust is equal to these two forces. Now if you look at forces acting along horizontal, we have one force that is acting to the left. We have 260 newtons, and this force has to be equal to this one because the resultant force is 0. The better way of writing is that we can say, in this case 260 newtons minus, we are taking to the right is positive, to the right positive, minus this one. So we have F sine of 33 degrees. This one has to be equal to 0 because the net force is equal to 0. Now from here simply we can write down 260 newtons, this is equal to F sine of 33 degrees. We need to find out F, so this will be equal to 260 newtons divided by sine of 33 degrees. If we solve this one, we will get 477 newtons. So this is our final answer. This question has 2 marks. The first mark you will get if you have equated these two components. So you will get 1 mark. So this is 1 mark. Then the second mark you will get if you have got the right answer. We can also use this one if we have value of u, and if we have value of mg, we can also use this one and we can find value of f. But for this question we don't have value of u, we don't have value of mg, so that's the reason we cannot use. So we have to use forces acting along horizontal. Part 2 says the boy floats due to the upthrust from the water. The weight of water displaced by the boy is equal to 2.9 kilonewtons. Weight of fluid displaced by any object is equal to the upthrust acting on that object. So it means value of upthrust is given to us, and we need to determine the weight of the boy. So again we can draw free body diagram, means we can draw the forces acting on the boy. So first of all we have one force that is acting at angle of 33 degrees. This force is the F, so this is the tension in the spring. And we have another force that is acting to the right. We have the horizontal force acting on the boy, and we have upthrust acting on the boy. This is in vertical direction upwards, and the weight of the boy is acting vertically downwards. So these are the forces acting on the boy. So we have upthrust that is equal to 2.9 kilonewtons, and we have this force that is equal to 260 newtons, and here we have the weight of the boy. Now we need to resolve forces along vertical, means we have to look at forces along vertical. As the boy is stationary, so the forces along vertical has to be equal to 0. So we have force upthrust that is acting upwards, so this is 2.9 times 10 to 3 newtons this is upward, we are taking upward direction as positive. And we have weight that is acting downward, so we can say this is mg. And we have component of this force, this component that is also acting vertically downwards, and this component is f cosine of 33 degrees. We can also write down minus f cosine of 33 degrees, and this one has to be equal to 0 because this boy is stationary. You can also simply use u here, so you can see the relationship between different quantities, and then you can plug in values and you can find the answer. For this question, we have to find out value of mg, so we can write on here mg. This has to be equal to up thrust, means 2.9 times 10 to 3, minus value of force we have already calculated, that was 477 cosine of 33 degrees. Now if we solve this one, we can find out the weight, means we can represent mg with w. This one will be equal to 2500 newtons. So this is our final answer. So this is how you can do these calculations. And this question has 3 marks. If you have resolved f into components, you have written this one, you will get 1 mark. So this will be the 1 mark. And the second mark you will get if you have equated forces along vertical, mean if you have written this, you will get an other mark. So this will be the second mark. And the third mark you will get if you have got the right answer. So this is how marks will be awarded to you. Part B says the speed of the water flowing past the buoy increases, so the horizontal force increases. Assume that weight of the water displaced by the buoy does not change. Weight of the water simply means that up thrust, so it is given to us up thrust remains constant. For this question, we need to explain how f and theta change when the horizontal force increases. So we can start first of all with vertical, mean the forces along vertical. We can look at forces along vertical. Along vertical, we have discussed that up thrust is acting upwards, and we have weight of the buoy that is acting downwards, and we have f cosine of theta that is acting downwards. Up thrust remains constant, weight of the buoy also remains constant. It means f cosine of theta also remains constant. We can resolve this force into 2 components. We can give 2 names to this. So this is our vertical component, and this one is our horizontal component. So we can rewrite this one. We can say w plus fv, this is equal to u. So this remains constant, w remains constant, so fv also remains constant, mean this component of force remains constant. Now we can look at forces along horizontal. So this is a systematic approach. Any question of this type you can answer using same technique. Along horizontal, we have horizontal force. We can say this is F capital H. This has to be equal to this component of force, mean this has to be equal to F sine of theta. As this force increases, this as a whole, this one has to increase. We can also say this is equal to F sub H. It means F sub H increases. Now we can write down F in terms of its component. So we can say F, this has to be equal to F H square plus F V square, V square. So in this case, it is given to us that Fv remains constant, Fh increases, so it means F as a whole, this increases. So this is one point we can say F increases. Now if you look at the angle, in this case we can say this angle, tangent of theta, we can say tangent of theta, this will be equal to Fh divided by Fv. As Fh increases, this remains constant. It means tangent of theta, this increases. Tangent of theta increases. As tangent of theta increases, it also means that theta increases. Theta increases. So if theta increase, this term, cosine of theta will go down. So F has to increase. So these are the points we need to understand to answer this question. So first thing we can say, horizontal component of force increases. Mean this component of force increases because it is given to us this component increase. If this one increase, it means this one also has to increase. So we can say horizontal component of force increases. Mean this component increases. We can say horizontal component of F increases. So this is one point we can write down. Horizontal component of F increases. And vertical component we have discussed, this remains constant. So this is vertical component. So we can say FV constant, it remains constant. So FV remains constant. FV remains constant because weight of the boy and up thrust remains constant. Then we can write down, we can say F square, this has to be equal to FH square plus FV square. So this remains constant, this one increases, so it means F increases. So we can say F increases. Then we can show with this one, we can say tangent of theta, this is equal to FH over FV. As FH increases, it means that tangent theta increases. Then you can also write down, you can say theta is equal to tangent inverse of FH divided by FV. As this increases, so it means theta also increases. So this is in a beautiful way you can answer, and this question is a very nice question to understand forces. A beautiful question. So try to understand this question. If you have clear understanding of this question, this can help you to answer a lot of questions from past papers. I hope this question was clear to you, and if you have any questions, please leave your questions in comments. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 18 says, a student inflates a balloon. She uses a peg to keep the balloon closed. She then attaches a straw to the balloon using sticky tape. She passes a string through the straw and pulls the string tight as shown in the figure. The student removes the peg and air leaves the balloon. The velocity of the balloon increases from 0 to a maximum value. Explain how Newton's three laws of motion apply to the motion of the balloon during this time. So this question is very important one, and when you write down your answer, you have to write down your answer in a systematic way. Means the steps have to be written in an order, not in a random way. So it's very important, you need to organize your thoughts. So first of all, if you look at this balloon, it is given to us the student removes the peg and air leaves the balloon. So when student will remove this peg, air will go this way. So this is direction of air. Why air will go this way? Because there is force on air by balloon. So we can say because there is force on air by balloon. By Newton's third law, there will be a reaction force on the balloon as well. So this has to be in the opposite direction. So this will be force on balloon by air. So this is reaction force by air, So this is by Newton's third law. So we can say this is by Newton's third law. Now we need to understand, as this balloon will accelerate, because the speed of the balloon will increase from 0 to maximum value, balloon accelerates. So we can say balloon accelerates. So we can say balloon accelerates. As balloon accelerates because there is resultant force. There is resultant force on balloon. So we can say there is resultant force on balloon by Newton's second law. And this balloon will reach a maximum value. It is given to us, it reaches maximum value. When balloon reaches maximum value, V max, resultant force on balloon will be 0. Resultant force will be equal to 0, because in this case force on balloon by air will be equal to the resistive forces. So by Newton's first law, resultant force will be equal to 0 by Newton's first law. So this is how you can include 3 laws of motion to explain the motion of this balloon. So it's a systematic way. So first of all, we need to understand why balloon will move. When air is released from the balloon, there is force on the air by balloon. So by Newton's third law, there must be a reaction force on the balloon. So this is how you can include Newton's third law. Then we can go and we can think about why balloon accelerate. When something accelerates, there must be a resultant force. And acceleration and resultant force are explained by Newton's second law. And then finally, this balloon will reach a maximum value. Now we need to understand, if the speed is constant, how about resultant force? Resultant force has to be equal to 0. And this is by Newton's first law, because when speed of the balloon increase, resistive forces also increase, and they will balance the force on balloon by air, so its speed will be maximum. So these are the things we need to understand. Now let me show you the answer, how you can write down your answer in a systematic way. So this is how you can write down your answer. You can mention these points we have already discussed. So you have to write down 6 points. So if you have written first one, you will get 1 mark for this one, and then there is a second one. If you have written the second point, you will get another mark. The forward force on the balloon is greater than resistive forces, you will get another mark. By Newton's second law, the resultant force causes acceleration, so you will get 4th mark, means 1 mark here. As speed increases, forces change until resistive force equals forward force, you will get another mark, means you will get 5 marks. And the last mark is, if you have written by Newton's first law, resultant force equals 0, so acceleration equals 0 at maximum speed, so you will get the last mark. So this is how 6 marks will be awarded to you. And this type of questions are very important and very helpful to improve your understanding of physics. So you can see how you can apply physics in a systematic way, and also this question helps you to understand how to look at practical applications of physics and how you explain any phenomenon in a beautiful way. Question 19 says the diagram shows a crane lifting a load. There is a large mass called a counterweight attached to the crane on the opposite side of the tower to the load. The crane has an electric motor with an efficiency of 47%. The crane lifts a load of 4.4 times 10 to 4 newtons. The load moves through a vertical distance of 15 meters in a time of 70 seconds. Determine the average power input to the electric motor. So for this question, first of all, you need to understand, imagine that this one is the electric motor. So we can say this one is the motor. So there is a power input, so we can say this is P in. So this is power input. This one has certain efficiency, and we will get P out. So this is the power out. Efficiency, we can simply write down efficiency, the percentage efficiency. This one has to be equal to useful P out divided by P in. So here we are talking about useful P out. So this is useful P out. P out has to be equal to P in, but P out will have useful power, so this will be P out useful, and also there will be P out wasted or dissipated power wasted. So this sum has to be equal to P in. So in this case we have P out. We can calculate P out is the useful work done by the crane, by the motor. We can calculate that one. So first of all we can say the P out useful. So P out useful we can calculate, that is equal to the work done by the motor to lift this load divided by time taken. So we can simply write down the work done by motor divided by time taken. So we can say delta T, and work done will be equal to force time distance, and force we have 4.4 times 10 to 4. This is equal to the weight of the load. So this is the force, and the distance we have, that is equal to 15 meters divided by time taken. Time taken in this case is 70 seconds. So we can calculate the value of P out. P out in this case will be equal to 9.4 times 10 to 3 watts. So this is value of P out. We need to calculate P in. So we can write on here P in, input power. This one has to be equal to P out useful. Very important ones. It's better to write down useful divided by the efficiency of this percentage efficiency. So this will be equal to 0.47. So this is 0.47. So we have P out, that is 9.4 times 10 to 3 divided by 0.47. So if we solve this one, in this case we will get 2.0 times 10 to 4 watts. So this is the P in. So one important point is you need to understand this has to be P out useful. Most of the time students, they simply understand P out over P in, and that is not right physics. So you need to understand P useful. So this is how we can answer, and this question has 4 marks. If you have written these steps, you will get the 4 marks. The first mark will be given to you if you have used this formula. W, if you have written W is equal to this one, you will get 1 mark. So this will be the 1 mark. And the second mark you will get if you have used W over delta T, you will get another mark. And next mark you will get if you have written P out in this form, P in this form, you will get 1 mark. And the last mark you will get if you have got the right answer. So this is how 4 marks will be awarded to you. Part B says the horizontal distance from the load to the tower can be changed. The horizontal distance from the counterweight to the tower can also be changed. Explain how the counterweight needs to move when the load is moved away from the tower. Means if we move this load away from the tower, how we need to move this counterweight for this system to be in equilibrium. So first of all we need to understand what is equilibrium, mean the conditions for equilibrium. For equilibrium, sum of the forces in any direction has to be equal to 0, and net moment about any point also has to be equal to 0. Net moment about any point has to be equal to 0. So it's very important to understand in any directions. So we can say resultant force in any direction has to be equal to 0, and net moment about any point has to be equal to 0. So this is very important, and this is complete physics, or we can say right physics. If you simply remember total sum of forces is equal to 0, that is not right way to state condition for equilibrium. Or if you only remember net moment is equal to 0, that is also not complete understanding of this concept. You need to understand net moment about any point has to be equal to 0. It simply means that sum of clockwise moments has to be equal to sum of counterclockwise moments. So this is one point we need to understand. So we can mark this one as 1 point. The second point we need to understand is when we move this load to the right, so clockwise moment, so this is the clockwise moment, this is our pivot, so the clockwise moment will increase, so CW increases. So we also need to increase the counterclockwise moment, so this one also has to increase. So how we can increase this one? We also need to move this one, this counterweight, to the left. So these are the points you need to understand to answer this question, and this question has 4 marks. So let me explain you how you can write down these 4 marks, and this is how you can write down these 4 marks. The first point, you can say total anti-clockwise moment is due to counterweight, means due to this counterweight. Total clockwise moment is due to sum of moment from beam and load, because this beam also has mass, so it has the center of mass. So from the center of mass, so let's center of mass somewhere, just approximate point, it has to be at the midpoint of this beam because this beam is uniform. So simply around here, I'm just marking here, so there is a weight of the beam, so this also will cause clockwise moment. So total clockwise moment is due to sum of moment from the beam and also from this load. Increasing the distance of the load increases the clockwise moment. So distance of counterweight needs to be increased to balance increase in clockwise moment, because net moment has to be 0 for this system to be in equilibrium. So this is how we can answer, and if you write down these points, you will get 4 marks. So here 1 mark for this one, and the second mark for this, and the third mark you will get for this point, and here you will get the 4th mark. This is how marks will be awarded. Second part says the beam is uniform with a weight of 3.0 times 10 to 4 newtons. The counterweight has a weight of 1.1 times 10 to 5 newtons. The load has a weight of 4.4 times 10 to 4 newtons. Deduce whether the load can be moved to the end of the beam without the crane toppling. Question is simply asking us, if we move this load to the end of this beam, this crane will topple or not. So this is what question is asking us. In order to answer this question, simply we need to understand for equilibrium, clockwise moment means the sum of clockwise moments has to be equal to sum of anti-clockwise moments. So we can simply say sum of clockwise moments has to be equal to sum of counterclockwise moments. So this is our main concept. We can also mark the midpoint of this beam. Midpoint will be around here. We have 1 2 3 4 5 6 7 8 9 10. It will be around here because we have 21 small squares, so it will be around here. So we can say this is weight of the beam is acting here. The length of this beam is 30 meters, so it means the midpoint is at 15 meters. This one is 8, so this distance, this has to be 7 meters. So we can say this is 7 meters. And for this load, we can just say for this system to be in equilibrium, let's say this length is equal to x, mean the distance from the center of the beam. Distance from the center of the beam, from here, from the center of this tower to the center of this load, let's say this distance is equal to x. So moment due to this one will be clockwise, moment is due to the weight of the beam also will be clockwise, and moment due to this counterweight, this will be counterclockwise. So we can say this will be counterclockwise. So first of all, we can look at clockwise moment due to the load. The weight of the load we have, that is 4.4 times 10 to 4 newtons multiplied by the distance from the center of the tower. Let's say that is x. Now we need to look at moment due to the weight of this beam. Weight of the beam we have, this is weight of the beam, so this is 3.0 times 10 to 4 newtons multiplied by the distance from the center of this tower. That distance is equal to 7.0 meters. Now we need to find moment due to this counterweight. The weight of this counterweight is 1.1 times 10 to 5, and its distance from the center of this tower is equal to 8.0. So from here we can find out value of x. If we figure out value of x, so this will be the maximum distance from the center of the tower. So x max in this case will be equal to 15.2 meters. So we have the maximum distance of the load, maximum possible distance from the center of the tower for this load has to be 15.2 meters for this system to stay in equilibrium. If we increase distance, this will just topple. So we can simply say this is the maximum distance without toppling. Now we need to find out the maximum distance we can move this load. Maximum distance means from here, and this maximum distance will be equal to, we have 8, so 30, this can be 22 meters. As in this case, as x max that is equal to 15.2 meters, that is less than 22 meters. So it means in this case this crane will topple if we move this load to the end of the beam. A practical question. If you look at the crane, when crane is working, and think about this principle of physics, you will see how crane works and how they adjust this counterweight. If they have to lift heavy weight or they have to lift lighter weight, so how they adjust this counterweight. Next time when you see crane in operation, look at crane carefully and try to understand the principle behind working of crane, means behind operation of crane. So you will see the real beauty of physics, means you will see physics in action. And this question has 5 marks. If you have written answer in this form, finally you have concluded, you will get 5 marks. Question 20 says an actor is wearing a harness. The harness is connected to a cable and support as shown in the figure. The force on the cable must not cause the material of the cable to reach its yield point. State what is meant by the yield point of a material. Yield point is a point at which there is a large increase in strain with small increase in stress. Or simply we can say yield point is a point at which there is a sudden increase in plastic deformation, or we can say is a large plastic deformation. That point we call is a yield point, and yield point is very important when we manufacture something or when we design something. So the safety factor is linked with yield point of a material. So let me show you how you can write down a proper answer. So this is how you can write down your proper answer. In the answer you can simply mention stress value at which material undergoes a sudden or large plastic deformation. That stress value is the yield point. You can see on this figure, this point is the yield point. Before this one, you can see the increase in strain and stress, they are proportional to each other, and after that there is a large increase in strain with small increase in stress, and material undergo plastic deformation. So this point we call is yield point. So this is how simply you can explain this question as only 1 mark. If you have written this one, you will get 1 mark. Part B says the cable and harness are used to accelerate the actor vertically off the ground. Explain why the forces acting on the actor cause him to accelerate upwards. So first of all, for this question, it is given to us actor accelerate upwards. So simply we can write down acceleration is vertically upwards. If acceleration is vertically upwards, so the resultant force also has to be vertically upwards. So simply we can say F net has to be vertically upwards. force. Now if you look at the forces acting on the actor along vertical direction, one force is the weight of the actor that is acting downwards, that is mg, and there must be another force on this one, that will be the pulling force, and the pulling force has to be greater than the weight. So simply we can say in this case actor is accelerating vertically upwards. It means there is resultant force acting on the actor along vertical. This question has 2 marks, so this is how we can write down our final answer. In the answer we can say the force from the cable on the actor is greater than the weight of the actor, so there is resultant force upwards. That's the reason this actor will accelerate upwards. So if we have written these 2 points, you will get 2 marks, one for first point and the second mark you will get for the second point. Second part says the actor has a mass of 77 kgs and is lifted vertically from the ground with an acceleration of 2.1 meters per second per second. Show that tension in the cable is about 920 newtons. As we already discussed that there are 2 forces acting on the actor along vertical. One is mg, that is acting vertically downwards, and one is the pulling force. We can say this is tension in the string, or we can say better way to say is the pulling force acting upwards. For this question we need to find out value of t, and acceleration in this case is vertically upwards. So simply we can start with F net is equal to ma, and F net has to be equal to t minus mg, and this will be equal to ma. We need to find out value of t, so simply we can say t is equal to mg plus ma, and we have value of mass, that is 77 kgs, and we have value of g, that is equal to 9.81. Again we have mass of the system, that is 77 kgs, and value of acceleration is 2.1. So we have value of a, that is 2.1. So simply we can plug in these values, and if we simplify, our final answer will be equal to 917 newtons. So this is value of t. So this is how we can approach this kind of problems. So the final answer for this question is 917. This question has 3 marks. 1 mark you will get if you have calculated value of weight. 1 mark you will get if you have used this formula. You will get 1 mark for this one, and the 3rd mark you will get if you have got the right answer. A beautiful way. So this formula is very important in mechanics. F net is equal to ma. Third part says to make sure the actor is safe, the stress in the cable must be less than 15% of the yield point stress. The cable has a yield point stress of 2.5 times 10 to 8 pascals. The diameter of the cable is given to us, and we need to deduce whether it is safe to lift the actor with an acceleration of 2.1 meters per second per second. We have already calculated the tension force, or we can say the upward force, that was equal to 917 newtons at a is equal to 2.1 meters per second per second. So we can find out first of all safe value of stress. So we can find out stress, safe value of stress. That has to be equal to 15% of yield point stress, 15% of this value. So we can multiply with 2.5 times 10 to 8 pascals, and if we multiply with this we will get 3.75 times 10 to 7 pascals. So this is the safe value of stress. Now we can find out the maximum value of stress. So stress maximum in the string, that one has to be equal to the force, pulling force, divided by the cross-sectional area of the string. Value of force we have, that is equal to 917 newtons, and value of A we can find out, that will be equal to pi by 4 d square. So we can plug in values, 917 divided by pi by 4. Value of diameter of the cable is given to us, that is equal to 7.6 times 10 to minus 3 square. And if we solve this one, we will get 2.02 times 10 to 7 Pascal. So this is the maximum stress. Now simply we need to conclude. So we can write down over conclusion. We can simply say as stress max, this value is less than this, so it's less than stress safe, means the safe value of stress. So it means that, so it is safe. So it means that this much stress is safe. So actor is safe if actor is accelerating with this acceleration, because the stress in the cable is lower than safe value of the stress, so it means that actor is safe. So this is how we can conclude. It's a practical question about designing, how designer works, how they make sure something is safe. And so this is how we can calculate, and if you have done this one, you will get 4 marks for this question. Total marks for this question are 4. Part C says the original cable is replaced with a new cable made from a different material. This material has a lower Young modulus than the material used to make the original cable. The new cable is the same length as the original cable but has greater diameter. The breaking stress is the same for both cables. Explain how the work done to break the new cable is different from the work done to break the original cable. Assume that both materials obey Hooke's law up to the breaking point. So for this question, it is given to us original cable. So we can simply write down here original cable, and we have new cable. So we can write down here first of all new cable. For these two cables, it is given to us they have the same length, so we can say they have the same length, and also they have the same breaking stress, same value of breaking stress. So these points we can write down. For new cable, it is given to us the diameter of new cable, this is greater than diameter of old cable, or we can say original cable. But Young's modulus of new cable, this is lower than Young's modulus of old cable. In this case, we need to compare work done, and work done is equal to force time distance. But in this case, it will be equal to force time extension. So we will write down delta x. So first of all, we need to find out force. To find force, we can use stress. Stress, the breaking stress, this is equal to the force divided by cross-sectional area. So we can say this will be equal to pi by 4d square. They have the same value of breaking stress, but in this case, value of d is greater. So if d is greater, it means force has to be greater. So the force on the new cable, force on new cable means F new, this one has to be greater than F old, or we can say F original, F old. So this value is greater, so we can update here, this value is greater. Now we need to find out a value of extension. To find extension, we can use Young's modulus. So this is Young's modulus, new value of Young's modulus. Young's modulus is equal to stress over strain, stress over strain. For this question, it is given to us this value of Young's modulus is lower, new value is lower as it is given here. Stress is the same, breaking stress is the same, so it means strain has to be greater, and strain is equal to extension delta x over x, or we can say delta L over L. You can also write down this is the extension divided by L original. They have the same length, but strain is greater, it means delta L is greater. We can also write down here this one is greater. We can also say delta L or delta X, it means extension. So extension is greater, force is greater. It means work done on new cable. This one is greater. So this is how you can answer this question. And these are the points you have to mention. So you can mention one, this point, same stress, area is greater, cross-sectional area is greater. It means the force on the new cable has to be greater. So we can mention these points in our answer. Then we can look at Young's modulus, as this value is lower, this value is the same, so strain has to be greater. As strain is greater but original length is the same, so it means delta L has to be greater, hence work done on new cable is greater. So this is a beautiful way, a systematic approach you need to develop in yourself, how to use a systematic approach to understand physics in a better way. I hope this one is clear to you. Now let me show you the final answer, how you can write down your final answer. I will clear this one and I will show you the final answer, how you can write down. In your final answer, we have to mention these points. We can say new cable has a greater cross-sectional area but same breaking stress, so greater force, because we have already discussed that stress is equal to F over A. A new cable has smaller value of Young's modulus, so there is greater strain for the same stress. So we can also say Young's modulus, this is equal to stress over strain. In a simple way you can write on here. So this value is lower, this value is the same, so this value has to be greater, this value is the same, this is greater, so this one has to be greater. So at breaking stress there will be greater extension because cables are the same length. So then we can also mention about the strain. So we have discussed these points. This is equal to delta L by L. If L is the same, strain is greater, it means delta L is greater. As force and extension both increase, so work done to break the new cable is greater than that for the original cable. So finally we can say work done, this is F times delta L. As delta L is greater for the new cable, F is also greater, so the work done is greater. So this is how we can answer in a beautiful way. I hope these questions make more sense to you and you have better understanding of these concepts. And that's all for today's lesson. If this video was helpful, please like and subscribe, and also you can join Patreon. If you need more help, you can also contact me directly for more help, and I'll see you in next video. If you have any questions, please leave your questions in comments and I will try to answer as soon as possible.